So this topic is very important.
Dr. Kamlakar Rajurkar is a world-renowned leader in manufacturing research. He studies the science behind non-traditional machining processes. And in doing so, Rajurkar, a professor of engineering at the University of Nebraska in Lincoln, has helped manufacturers take full advantage of new high-performance materials. Manufacturing plants are filled with machines that grind and cut. Rajurkar studies ways to do it differently, with machines that shape with electric sparks and electrochemical action. Traditional machining requires a cutting tool that is harder than the part being shaped. But electrical discharge machining, EDM, electrochemical machining, or ECM, and similar processes cut through hardened steel alloys and titanium, creating tiny and intricate features, from surgical tools to precision parts in jet turbines. Rajurkar was a graduate student at Michigan Technological University when he had his first exposure to EDM. Later, at the University of Nebraska, he coupled state seed money with federal and industrial funding to build the Center for Non-Traditional Manufacturing Research. Soon, it drew students and faculty from around the world. Rajurkar has helped companies improve manufacturing processes by delving into the science behind their tools. He's developed sensing and control systems and tools that are cryogenically cooled. Most recently, he's been researching micro-EDM and nano-electromachining. Rajurkar travels and presents his research around the world and has been recognized by manufacturing and professional associations. He's organized symposia and reviewed articles for ASME, and he's helped establish new advanced manufacturing initiatives as a program director for the National Science Foundation. For his contributions to non-traditional machining processes at all scales, and for research in process modeling and sensing control, Dr. Kamlakar Rajurkar is being awarded the ASME SME M. Eugene Merchant Manufacturing Medal.